Hi, welcome back to this Intro to Machine Learning course. Today, we're not actually talking about machine learning, but exploratory data analysis. As any good data scientist knows, we don't jump into the modelling before we know at least a little bit about the problem we're attempting to solve and the data we have available. We're going to break this down into three parts. First, we're going to learn how to perform basic statistical analysis of the data, known as numerical EDA. We'll be using NumPy and pandas in Python to do this. Then we'll move on to visual data analysis, which is plotting distributions and relationships between variables to identify what could be key drivers in our classification model. The libraries that we use for this are matplotlib and seaborn, which operate on top of the pandas data frame. Finally, you will have the chance to try this out for yourself in Python with some resources that we set up for you. Let's kick things off with numerical EDA. For this course, we'll be using the inbuilt analysis methods in pandas, which is one of the most important libraries in Python for data science. We'll cover three of the most common and easy to use now. The first of these examples is head. Before we do anything with our data, we want to take a look at it to check it makes sense and looks reasonable. Head is a method that allows us to return the top n rows of a data frame, defaulting to 5. After we've imported pandas and NumPy into our session, we read in our dataset. Here we're using the famous iris flower dataset, and then simply call the method head to view the top 5 rows. If you're not running this in a Jupyter notebook, you'll need to add a print call to see the output. Next up, we have info. This method returns high-level information about the pandas object, in this case, a data frame. Again, once our data is loaded, it's very simple to call this method with .info. Let's look at the results. The object type is a pandas data frame. The range index refers to how many observations are in our data frame. In this case, we have 150. Then we have 6 total columns in our data frame. Here we can see the ID variable is an integer. All our features are floating point numbers, and the species is an object, as it holds the name of which species the flower is. There's also some additional information about the memory usage that this is going to take up. The last of the core pandas methods we're going to cover is describe. This is the easiest way to return a quick statistical summary of your numerical columns in your data. Perfect for an initial basic analysis and getting an idea of the distributions and high-level trends in your data. As with the previous two, we load our data and call the method .describe. Compared with the last two methods, however, this is the beginning of the statistical analysis. The output return is a table consisting of the count, mean, standard deviation, minimum and maximum values, and each of the quartile values. You need to use a little bit of common sense when looking at the output. In this example, the ID column is included as it is numeric, but holds no statistical value for our analysis. So, to recap our basic pandas methods, head shows the top n rows of the data frame, and this defaults to 5. Info gives a concise summary of the data frame, and describe gives us descriptive statistics of the numerical columns in the data frame. Let's move on to the visual part of our analysis, plotting. Here we will use matplotlib and seaborn to show the underlying patterns and trends in our data. We want to improve our understanding of the data, and the easiest and most effective way of doing this is visually. In our iris example, we want to understand whether the petal length and width have an influence on the likeliness of a flower being a certain species. Visualizing data is a great way to spot patterns. Being able to plot values in multiple dimensions, using different types of charts, and making use of colors can really improve how we see and compare the data. If you're sharing analysis with others in your team, or especially non-technical stakeholders, a chart can be much easier to understand intuitively compared with statistical measures. A boxplot is a great simple way to compare how a numerical distribution varies when split by a categorical variable. Here we're comparing how the petal length distribution is different for each of the species of iris. The box part of the plot shows the median and interquartile range, whilst the n lines represent the minimum and maximum values. As we can see, the median values for the three species are very different. If we had a simple model to predict iris species using only the petal length, it might be reasonable to have a rule that says if the length is low, call it a setosa, if it's medium, call it a versicolor, and if it's high, call it a virginica. However, the boxplot also shows us that there is an overlap in the range of values between the versicolor and the virginica. This means that our simple model would only be effective at distinguishing setosas, but would struggle to separate versicolor and virginica. The violin plot is an extension of the boxplot. Instead of only plotting the quartile and extreme values of the distribution, the violin adds a smooth density curve to the plot. This gives us a deeper understanding of how the variable is distributed. The distribution of petal length for all three species peaks around the median value, but the spread varies for each one. The setosa species is tightly distributed, with most of the values around the median. The overlap between the versicolor and the virginica becomes more pronounced in the violin plot, because the box plot is only showing a point estimate, whereas the violin estimates the whole distribution. Both the versicolor and virginica species have a lot of observations around the 4 to 5 centimeter range. So far, we've only looked at each feature independently, as it differs with respect to iris species. We came up with the hypothesis that the setosa can be identified purely by petal length, but we need more information to separate the virginica and versicolor. The pairplot function from seaborn is a quick way for us to see how each pair of features interacts with each other. We can see the distribution for each variable independently on the diagonal of the plot. This is showing us similar information to the violin plot, but the real value here are the pairwise plots. Previously, we would have separated virginica and versicolor here, but we can see the overlap of values, reducing the accuracy of this prediction. Now when we include petal width, we can see a better line of separation between the two classes. For each of these plots, we've used seaborn in Python, but there are many alternatives. Seaborn and matplotlib are the most commonly used libraries in Python for plotting. Matplotlib is really powerful and customizable, but we're using seaborn because it's just so easy to use. We provided some resources for you to get started with EDA, but it's up to you how you go about analysing the data. This is an opportunity for you to also experiment with different analysis methods and explore different datasets.